The sixth lecture is on these obscure little things that we call sedimentary structures. They are put here because they're another way in which geologists can tell the environment. So the definition, as it says there, equals they're just features of sedimentary rocks that form during deposition. So as those sediments are laid down, they'll make these unusual shapes that we're going to see in just a minute, and then they help tell you about the environment that they were made in. This is a prime example of uniformitarianism. The present is the key to the past. So let's look at them. The simple first example is that of mud cracks. Everybody's seen mud cracks. The upper picture is from a pond that dried up just a few days ago from the picture being taken. And what it indicates, as any mud cracks do, is that there was a wet period where the mud was wet, maybe covered completely in water, and then it dried out. And as it does, mud breaks into these very distinctive polygon shapes. That's very characteristic of non-marine environments, and it's associated with some continental fossils. A lot of times trace fossils. So if you picture a little pond and maybe a little bird walks around the edge of this muddy pond and leaves its little footprints in there, those things can get preserved and they indicate a non-marine environment. The lower picture is an ancient example. This is many millions of years old, and in fact elsewhere off the picture here there are actual dinosaur footprints associated with this, but it's mud cracks. So again, you just have to see that and say, that place many hundreds of millions of years ago had a wet period and then it dried up, and little creatures walked by, or big creatures walked by and left their footprints. Very, very useful, important type of sedimentary structure is the ripple, and ripples indicate fluid motion, mostly water but also wind. And so the lower picture, lower left, has a little crab walking over a beach, and you can see the little ripple marks there, and the ripple marks formed as the tide went out and the water flowed from the land out into the sea. And what that does, when water is in motion or wind over a bunch of little sediments, it piles them up into very, very distinctive ripple shapes. The upper right picture has a geologic hammer in it for scale, and there you're looking at some ancient ripple marks. Those are rocks, but the ripples were made in that sediment and then it was preserved in place just like that. And that immediately tells us that it formed in a similar environment to the one that we're looking at in that modern picture. The very big important fact about ripples, that's why there's an exclamation mark there, is that they can indicate the direction of motion of the fluid. So if you have perfectly symmetrical ripples, notice each one of the little peaks of these things is called the crest, and if the right side is the exact same shape as the left side, we say it's symmetric. It's like the left side and right side are looking at each other in the mirror. And what that indicates is that water has sloshed or moved in a back and forth motion in a place like where the tide comes in and out. But a more important type of ripple is the lower one, the asymmetric ripple. Notice here, if you drew a little line at the top of each of these crests, the right side is very steep and the left side is very low sloped. They're not the same shape. It's asymmetric. And the way sand works, and when you make ripples, is that the water is moving. Notice here they have the little current arrow. So water is moving from left to right in this picture. The little sand grains bounce up and down. They bounce. They climb up this hill. They reach a certain steepness, and then they slide down. If you've ever poured sand out, say, of a bucket on the beach, you know, it pours into a pile, but you can't build a vertical wall of sand unless it's all wet, like when you're building a sand castle. But if you just have loose sediment, it kind of builds to a particular angle and then it falls. And this type of ripple, if you have it, see it like this, asymmetric, it can indicate that there was a current. And the best thing is that it can indicate the direction of the current. So if your resource is oil and gas is formed mostly in the oceans, we know rivers flow to the oceans. Your resource, your place to drill, your place to exist is off to the right. If, on the other hand, you are looking for continental fossils or dinosaur fossils or fossils of anything living on the land, you would look in the opposite direction. Very, very important. Again, expect some cartoon on the exam that then has a picture like this, and I would ask a question for the figure above, and I'd strip any arrows off of it. The direction of water motion is A to the left, B to the right, C back and forth, D cannot tell, or something like that. So figures are going to be very important. Here's another sedimentary structure, the crossbed. And the crossbeds are really like giant ripples. That's one way to look at them. And they are typically made by huge current flows, like giant wind storms or very large rivers. They also indicate current direction. So there's the upper picture, a cartoon of crossbeds, but the better one is the lower right, which is a whole mountainside of Jurassic age, so from the time that dinosaurs were all over, of giant ancient sand dunes. The tree at the top of this mountain here is probably, almost 100 feet tall. And so you can see this is like slicing into ancient dunes that kind of washed or were blowing back and forth over the continent at the time. This is a similar environmental address diagram, but this one comes from a dinosaur book. And so this would say these are different environments where dinosaur fossils are more likely to be found. So first of all, notice that in the oceans, you don't see much. It says rare bones, and that comes from maybe a dinosaur died on the beach or in the river and barely got washed out here. Dinosaurs didn't live out here, so they wouldn't find them. But on land, in lagoons, deltas, estuaries, etc., you could find all the different types of fossil dinosaur remains in here. And again, you would use things like ripples, mud cracks, crossbeds, all of that to say dinosaur fossils, bones, tracks, whatever could be in the vicinity, or they could not.